This is Euclid Book 2, Proposition number 11, Part 3. And we're going to start with rectangle CFGK. CFGK. We're going to start with this rectangle here. And what we're going to do is we're going to subtract from it rectangle ACKH. Well, let's find ACKH. ACKH. This area here will be subtracted from this whole rectangle right here. And we're going to do the same thing to ACDB. Well, here's ACDB. And what we're going to do is we're going to subtract the rectangle ACKH. All this area in here is going to be subtracted from this giant square. And when it is, then what we're going to have is AFGH, this area right here, and it's going to be equal in size, the area inside of here is going to be equal in size to KHBD. Well, here's KHBD. This area here is now equal to this area here. Now, the next thing we can say is the rectangle KHBD, this whole rectangle right here, is actually the rectangle ABBH. And why is this? Because AB and BD are exactly the same size. So we could actually put A right here. Okay? So KHBD is now ABHK. Okay? Now, AFGH. Let's go to AFGH. AFGH is actually the square of AH. Okay? Now, why is AFGH the square of AH? Well, that's very simple. You see this line here is equal to this line here, equal to this line here, and equal to this line here. All four of these lines are equal. So that makes it a square, and because one of its sides is AH, then this square is the square of AH. Therefore, the rectangle ABBH, this whole area here, is equal in size to the square of AH, which is right here. And that finally means that the line AB, right here, the line AB, has been cut at H, right here, so that the rectangle ABBH, this rectangle here, equals AH. And that was what it was required to prove. Now then, how does all of this relate to the quadratic formula? Well, in my next video, I'm going to explain that, and I'm also going to tell you how this makes the golden ratio. Stay tuned for that because you don't want to miss this.